Alright, today we are talking about equations of tangents. So basically what we're going to do is kind of extend what we were doing in class today and in the previous class, where we use the derivative of the curve to actually come up with the equation of the tangent line at the given point. So in this box over here, basically this tells us the main formula that we're going to use. This should be rather familiar because this is basically our point slope formula with a couple of the letters modified to fit what we're doing. Right, so instead of m, we're using f prime, and instead of x1 and y1, we are using a and b to represent the point that we are given. So if we look at this example, we need to find the equation of the tangent to y equals x squared at x equals 4. So we have a formula and an x coordinate. So what we are going to need is a slope and a y coordinate. Right? So we know our slope is found using the derivative. If y equals x squared, then the derivative is 2x. If x equals 4, then our slope is 8. If y equals to x squared and x equals to 4, then y has to equal 16. So our equation, y minus 16 equals 8 times x minus 4. And unless they say otherwise, we can give this as our answer, but if they do ask for it in slope-intercept form, we can just simplify the equation that we have. So y minus 16 equals 8x minus 32. So y equals 8x minus 16. Alright, that's all there is to that. I will leave B to you. So for example 2, we need to find the equation of the tangent at the given point and find where the tangent meets the curve a second time. So if I am sort of sketching this graph out, if I type in y equals 2x cubed minus 5x plus 1, I should get a graph that looks something like this. Again, this is a sketch, it's not exact. I know that my tangent is going to hit the graph somewhere on the left side, and it's going to, brush up against the graph. So assuming I've sort of sketched this out correctly, it's going to go something like this, which means that we are actually looking for this point over here. Well, in order to get that, I'm going to need an actual formula for my tangent line so that I can graph it and see it exactly. So again, we're going to take the derivative of f of x, and then we're going to plug in the point that we were given. And then we'll use our original equation to get the y value. And then use our point slope to get the tangent line equation. So y minus 4 is equal to, so our slope is 1, so we can kind of ignore that, which means that y equals x plus 5. So if I go back into my calculator and I graph x plus 5 in the second equation, it looks pretty much like I guessed. So we've got our tangent line. We're looking for the second point of intersection. So what we're going to do is go second, calc, and intersect. I'm going to scroll over until my cursor is close to the second point and enter 3 times. And it's going to tell me that they cross when x equals 2 and y equals 7. Alright, that's all there is to that. I will let you try B on your own. Let's look at our last example of the day. Okay, so we want to find the point where this equation has its tangent line at x equals -1 cross through the x-axis. So we know that every point on the x-axis has a y value of 0. Let's come back to that later when we need it. So, again, we need to write the formula for the tangent line, which means we need a slope. And our slope is -1. We also need a y value. So again, we'll plug back into the original formula. That should give us 6. So our tangent line formula, y minus 6 equals -1 times x minus -1. So we can simplify this, but remember, we just said we need a point on the x-axis. If the point on the x-axis has a y-coordinate of 0, I might as well go ahead and plug in before I start simplifying. Now remember, you can do this in either order. But this way is going to be slightly faster. So we plug in y, now we can solve for x. So x equals 5. It wants the point on the x-axis, so technically that's 5, 0. And that's it. That's all we have for today. I will see you next time.